All right, guys, we're gonna do lesson 4 today, unit conversions. And so I'm going to go over how we're gonna do unit conversions in this particular class. We're gonna learn a very powerful conversion method called dimension analysis. Now, I'm sure that at some point all of you have made a unit conversion before, whether you're converting between pounds to kilograms, or meters to kilometers, or grams to kilograms, or cups to pints, something along that lines. You've made some conversions. Whether they're in a math class, another science course, or just in everyday life experiences where you've had to convert one unit into another. All right. Now, there are different methods in converting units, say going from 15 grams of some object and determining how many kilograms that would be equal to of that object. There are different ways to do that. Some teachers show you how to, if you're using metric units, how to move the decimal point. Others show you what are called unit relationships. That's how units are related to one another. For instance, if I have, I know that 1,000 grams, okay, is equal to 1 kilogram. That's a unit relationship, also known as a conversion factor, because it allows us to convert from one unit to another. All right. We also may know something like 100 centimeters is equal to 1 meter, right? Or like 2.2 pounds is equal to 1 kilogram. We know that like 12 inches is equal to 1 foot, okay? And so forth and so forth. So we have these relationships where we're able to understand how to convert from one unit to another by knowing these conversion factors or unit relationships, okay? What I'm going to do is I'm going to show you how to use these unit relationships to solve more complicated types of conversions over time using the process called dimension analysis. Now, if you have your study guides out, I'm going to grab my study guide. Again, we're looking at unit conversions here in your study guide. And on that page, front page there, you have some unit relationships, and then you're given a whole bunch of those unit relationships right here. Now, many of these unit relationships we're going to use throughout our course in chemistry. All the metric ones that are listed here, you should probably know, or in other words, memorize for the test, know them really well. If you need like a English to metric conversion factor, I will give you that on the test, so you have access to that. Basic English to English, like inches to feet or whatever, you should probably know some of those basic ones as well that we use quite a bit in our everyday life, okay? So how do we use these and use this with dimension analysis, okay? So let me show you. Erase this here on the board. All right, let's start out with some simple ones, okay? And then we'll go to some more complex ones. In fact, the reason why we're doing this is to start out with some very simple ideas of converting units, things that you're already familiar with, so that when we get into more complicated types of conversions later on in this course, such as stoichiometry, you'll be able to go, oh, I know how to use dimension analysis. I can convert these complicated units that we have in chemistry, okay? So let's set you up with a problem, and then we're going to show you how to solve that problem using dimension analysis. So let's say we have an object that has a mass of 1.2 grams, okay? 1.2 grams. And we want to know its equivalent mass in kilograms, okay? Kilograms. Now, first of all, in order to convert from grams to kilograms, we do need to know a relationship between those two units. We need a conversion factor. So if you look, if you don't know the conversion factor between grams and kilograms, you might want to use your study guide and find that relationship at the top of the page in your study guide. What is that? Grams and kilograms. Well, it is 1,000 grams is equal to exactly 1 kilogram by definition. Okay? Now that we got that taken care of, I'm going to set up this problem and show you how to do it, dimension analysis. Now, I do not want you to use any other method. Now, normally I typically don't say that. I usually tell you to use a method that you feel most comfortable with to solve problems. But in this case, and in this class, I would like you to use dimension analysis to solve your conversions. Even if it's a simple conversion, I want you to get familiar enough with dimension analysis so that it is automatic when you get into very complicated conversion problems that you just cannot do in your head or you can't do with another method. And dimension analysis is the only way you can really do it. Without dimension analysis, things can get really difficult. With it, things can be really easy. So learn the process and learn it well, okay? Practice. And I'm gonna give you plenty of opportunities to do that. So let's show you how I would set up solving this problem using dimension analysis. The first thing I would do is take my known value, the value that was given to me, which is 1.2 grams. And I'm going to put the unit along with the value. It's really important that you do not slack on putting units when you're using conversions in the dimension analysis. It will save you a lot of problems down the road, okay? So what I'm going to do is I'm going to put this value, this over 1. So I'm kind of making it into a fraction. And then I'm going to put brackets, or what we call posts, around that fraction, right? Again, this is what I'm starting with, 1.2 grams. Now I'm going to do this for every single conversion problem I have. I'm going to take what I'm given and I'm going to place it over 1, a fraction, and then put these brackets or put these posts around it, okay? And then what I'm going to do is right next to it, I'm going to make another post, okay? Now, what goes in this post is our conversion factor, okay? Now, our conversion factor, one of these units, the gram, is either going to go on the top or it's going to go on the bottom, and the other unit, the kilogram in this case, is going to go on the other, either top or bottom. So we have to determine which one of these units goes top or bottom of this fractional line. Well, in this case, we're going to put the gram on the bottom. Just going to put a gram there. Now, why am I going to do that? Is because I want to get rid of that unit, okay? And so units that are diagonal of one another are able to be canceled out, or we're able to eliminate that unit. So the gram is going to go on the bottom here, and I'm just going to put the value of 1,000 along with that, and then put a kilogram on the top, and actually 1 kilogram, okay? So what that does, again, is allows me to cancel out those units, because essentially what we're going to do is take our 1.2 grams and we're going to divide it by 1,000 grams, more or less. And when we take a unit divided by another unit, if they're the same unit, they cancel out or eliminate, right? So the unit that you always want to get rid of has to be diagonal of the other unit, right here, diagonal, one another. That's really important to remember, okay? Now, if you want to, of course, you can do this in your head, or you can use a calculator once you got your dimension analysis set up. I know I'm done because I'm trying to get to the kilogram, and that's going to be my final unit because it's the gram cancels out and the kilogram does not. So how am I going to do the math here is I'm essentially going to take 1.2 grams and I'm going to multiply it by my other top unit, whatever this value is. In this case, it's just 1. So I'm going to take 1.2 times 1, and then I'm going to divide my answer by 1,000. And that should give me my answer. Now, again, you can do that in your head, or in some cases, if the problem is more complicated, and again, this is an easy problem you can do in your head, but you can always use your calculator and plug it in. So I'll show you calculator-wise. Again, 1.2, multiply it by 1 times 1, which is just 1.2, and then divide it by 1,000, and I get my answer of 0.0012 kilograms, okay? Now, I probably should express my answer in correct number significant digits, okay? Like any answer or calculation you do. With dimension analysis, the way we're going to handle significant figures is the number of significant figures that is an original value, original measurement here, in this case, 1.2 grams, that number of significant figures is going to be the same number that's in my final answer. So if I have 2 significant figures here, I've got to end up with 2 significant figures here, which I do. These zeros are just placeholders. They are not significant because they come at the beginning of our number, okay? So I can leave it like this, or I can go ahead and put it in scientific notations of 1.2 times 10 to the minus 3 kilograms. And that's my final answer. I'll box it, okay? So hopefully that seems not too hard at first, okay? And this whole process is known as dimensional analysis, okay? So let's do some other ones. Let me erase this. Let's do something different. Let's do also a fairly simple one, but let's do an English unit to a metric unit. So let's say, let's do something like pounds to kilograms. So let's say I have 400.2 pounds, and I want to know how many kilograms that is. Okay. Now again, in order to solve this problem, I need to have a unit relationship between pounds and kilograms. Okay. Well, it so happens that on your study guide, this conversion factor is there. Okay. Or you can always look it up, Google it or something. But there are 2.2 pounds for every 1 kilogram. Okay. Right, so now that I got my conversion factor, now I just need to set up my dimension analysis problem. So again, I'm going to take my original measurement of 400.2 pounds. Again, I'm putting the units there. Again, over 1 with my brackets or my posts around it, okay? And then right next to it, I'm going to make my second bracket, and that again is going to be my conversion factor. And I need to decide, do I put the pounds top or bottom, or the kilogram top or bottom? Well, since this is pounds and I want to get rid of pounds, I need to put pounds so that is diagonal of one another so that they cancel out. So I'm going to put 2.2 pounds there and 1 kilogram on top, right? And since the pounds eliminate, leaving me with just kilograms left, I am done with the problem other than the actual calculation. So remember before, we take our value, our 400.2, we multiply it by the top value and then divide it by the bottom value. Again, since that's 1, I'm going to take my trusty calculator, hopefully, 400.2 times 1 divided by 2.2, and I get 181.9090909 kilograms. All right, so now I got to deal with the significant digits. I'm starting out with 1. Those zeros are significant because they're sandwiched. So 1, 2, 3, 4 significant figures. I can have 4 significant figures here. So my final answer is 181.9 kilograms. Box my answer, and I'm good to go. 181.9 kilograms. All right. Hopefully, so far so good. All right, let's erase that and let's do another one. All right. Let's do something like, let's do something in English units again. Let's do feet and inches, okay? So let's say we have 2.46 feet. And how many inches does that equal? Okay, so again, the conversion factor for feet and inches is 1 foot is equal to 12 inches. Okay, so I'm going to set up my problem of 2.46 feet. Okay, over 1, my brackets, and then I'm going to put my conversion factor next. Because feet is the unit I want to get rid of, I'm going to put 1, I'll just put feet, 1 feet on the bottom, 12 inches on the top. And then I can go ahead and eliminate the units that I can get rid of. And then I'll do my math. Again, I multiply the top values and divide by the bottom value. So I'm going to take 2.46 times 12. 2.46, multiply that by 12, and then again divide by 1, and I get an answer of 29.52 inches. All right, significant figures, I can have 3, so I need to round to 2.5 inches as my final answer, okay? My significant figures match up. All right, there we go. All right, these are the basic types of problems. Again, many of them you can do in your head because you've learned certain methods or styles in order to do so. But I really want you to do this dimension analysis, and I'll expect to see this on your homework, quizzes, tests, and whatever else we do in class, okay? All right, let's do some more complicated ones. Okay, let's expound on this. All right, let's do something. Let's say we have, let's say 4,000.34 centimeters, okay? And we want to convert this into kilometers. Centimeters to kilometers, all right? Now, here's an example of a possibility that I may not know directly how to go from centimeters to kilometers. In other words, I may not have a unit relationship for it. Maybe I do, maybe I don't. I don't know, okay? Maybe on the test, I give you different conversion factors, and you might have to use multiple different conversion factors or unit relationships in order to solve a problem like this. For example, I know that there is 100 centimeters in 1 meter. I also know that there is 1,000 meters in 1 kilometer. okay? So I know these relationships, I just don't know for certain what is the relationship between centimeters and kilometers. Maybe I do, maybe I don't. But let's pretend in this case that this is all I know, is these two unit relationships, okay? So what I need to do is solve this problem, convert centimeters to kilometers using these two unit relationships or unit conversion factors, okay? So how do I do that? Okay, so I'm going to take, again, like normal, my original value of 4,000.34 centimeters over 1, put my brackets or my posts, and then I'm going to put my conversion factor post, okay? That's normal. Well, the unit here is centimeter. So which one of these has centimeter in it? Well, the top one. Okay, I need to get rid of centimeter, so I'm going to put centimeter on the bottom because they're diagonal. So when they divide, they'll cancel out. And I'm going to put 100 as my value, 100 centimeters, which is equal to 1 meter. All right, so I know my centimeters cancel out, but meter is not my final unit. I need to get to the kilometer. So I need to go one more step. So I need to add a second bracket or a second conversion factor here. All right, and I'm going to use my bottom one now. So my meter here is on the top. So in order to get rid of that meter, I'm going to put a meter right here and the kilometer on top. So 1,000 meters to 1 kilometer. So again, divide a meter by a meter, the meter units cancel out. So the centimeters cancel out because I divide those. The meters cancel out because I'm dividing those. It gives me the kilometers left. So now I have a little bit more complex dimension analysis problem, but not, overly complex. I'm just adding 2 conversion factors instead of the 1. And then I can solve my problem. Bring out my trusty calculator if I need it. And I will put in the values. So 4,000.34. Remember, I multiply first, so times 1. And then I divide the bottom value, divide by 100. And then I take that and multiply by the top again. So I'm multiplying by 1. And then finally, I divide by 1,000. And I get my answer of 0.0400034 kilometers, okay, or kilometers. Now I have to deal with significant digits. Well, I have 1, 2, 3, 4, 5, 6. So I need 6 here. Now these 2 zeros are not significant, so they're just placeholders. So I need the 4. I need basically 1, 2, 3, 4, 5, 6. So I really need all of these. So really, technically with significant figures, all of these are included. If I put in scientific notations, then it would be just 4.00034 times 10 to the minus 2 kilometers. So I can do it in scientific notations as well on there. So I might have to put multiple brackets if I'm using more than one conversion factor to answer a particular problem, okay? So sometimes we might have 3, 4, maybe even 5 different brackets, depending on what conversion factors that are accessible to me. All right, so let's combine some things we know into another problem. Let's do something like this. Let's say we have 6.21 grams, and we want to convert that into pounds, okay? So what we do know is there's 1,000 grams is equal to 1 kilogram. That's one conversion factor. And we know that there are 2.2 pounds. I need to change that, dyslexic moment. pounds is equal to 1 kilogram, okay? So I can convert from grams to pounds going through the kilogram, using that as a common relationship that I understand or know. So again, I'm going to take my 6.21 grams, okay, over 1, there's my brackets, and then I'm going to put, because this is the gram, I'm going to put a gram here because I need to get rid of it. So I'm going to put 1,000 grams and then 1 kilogram on top. That gets rid of the grams. Now I have kilograms. But again, I want pounds, not kilograms. So I need to get rid of the kilogram, to pounds, 2.2 pounds on top. Okay? So I've set it up so my grams cancel, my kilograms cancel, leaving me with pounds, the only unit left. So now I'm going to take, again, my trusty calculator, and I'm going to take 6.21 divided by, or I'm going to multiply by 1 first, which is going to just be 6.21, and then divide by 1,000. And then take that answer and multiply it by 2.2, and then divide by 1. So my final answer should give me 0.013662 pounds. But I don't want that number of digits. I need to reduce it down to 3 significant figures. So in scientific notations, it would be 1.3, round to the 7 there, times 10 to the -2 pounds. And that will give me my final answer, reported the correct number of significant digits. Okay? So again, an example where I might have to use 2 brackets instead of the 1 because I got 2 conversion factors that I'm working with. If I have 3 conversion factors, then I have to add a 3rd one. If I have 4 conversion factors, I have to add another one, and so forth. But the math is still the same. Just make sure that the units you're trying to get rid of are on the bottom. They're diagonal from one another, okay? So I can divide and get rid of them. And so the last unit that's left, that's the unit in my final answer where I'm trying to get to, all right? All right, let's try something different, okay? Let's try one in which we have 2 units that we're trying to get rid of, okay? 2 units now. So let's say we have a problem where we have, say, 27.01 meters per second, okay? So this is like a speed, right? This is the amount of speed, or it might be velocity, depending on what you're looking at. But essentially, I'm going 27.01 meters per second. And I actually want to turn that into kilometers per hour, okay? So how would I do that? Well, I need some time conversion units, and I need some distance. So I do know right off that 1,000 meters is equal to 1 kilometer, okay? So that deals with my distance unit, but what about my time? Well, if I don't know how many seconds are an hour, I can do some reasoning. For instance, I might know that there are 60 seconds that's in 1 minute. And I know that there are 60 minutes in 1 hour, okay? And so there's my time from seconds to hours, okay? Now, how would I set this problem up? Well, same idea. I'm going to take my meters, my 27.01 meters, and now, because this second is a unit that's on the bottom, I'm going to place it over 1 second, okay? This is a 1, so over 1 second, and then I put my brackets. So now I have my meters per second, okay? So now I need to get rid of my distance unit or my time unit, one or the other, but choose one. It doesn't matter which one you choose first to eliminate. I'm going to go ahead and choose the meter, my distance first. And so I'm going to make my bracket here, and I'm going to use my distance conversion factor, 1,000 meters to 1 kilometer on top. Now, when I divide these two, I get rid of the meter. Gives me kilometers, which is what I want on top. Notice the kilometers on top of our division sign. So I'm in good shape. Now I need to get rid of time. So I need to add another bracket to start getting rid of time. Well, the second is on the bottom. So in order to eliminate the second, I need to have the second on the top. Remember, they have to be diagonal because I'm dividing them to get rid of them. So that means I'm going to use my 60 seconds on top and my 1 minute on the bottom. That eliminates the seconds, and now I have kilometers per minute. But I don't want kilometers per minute, I want kilometers per hour. So I'm going to actually have to add a whole nother bracket here, okay? Now, since I want to get rid of minutes to go to hours, my minutes on the bottom here, so I'm going to put 60 minutes on top so that these two are diagonal of one another, so they eliminate one another. And then I'm going to put my 1 hour on the bottom. Now, look what's happened here. If I scan my units here, all I have left is kilometers per, there's my division sign, per hour. And that's exactly the units I'm looking for, kilometers per hour. So now I do the math. Once I know the units check out, I do the math. So I'm going to take my 27.01, divide by 1,000. Okay, because I'm multiplying by 1, so times 1, divide by 1,000, then take that answer and multiply it by 60. Then divide by 1, take that answer and multiply by 60 again, and then divide by 1. So once I do that, my answer becomes 97.236 kilometers per hour, okay? But I got to deal with significant digits, okay? I have 4 significant digits. I can have 4 here. So my real answer should be 97.24 kilometers per hour, okay? Once all this is said and done, okay? Kilometers per hour. Double check my math on that again. So 27.01 divided by 1,000, okay, times 60. 60 again. Okay, yep, 97.24 kilometers per hour. Okay, is the idea. All right, so there's how you can solve when you have 2 different units that you're trying to convert, okay? One of those units goes on the top, the other one goes on the bottom, and then kind of solve from there, okay? All right. One last type of problem that I'm going to show you, and that is if we have like squared or cubic types of units. So let's say we have something like 1.34 meters that are cubed. Okay, so we have a volume unit. Okay, 1.34 cubic meters. And I want to find, say, cubic centimeters. Okay, so how would I solve for that? Well, I know that there's 100 centimeters equals 1 meter, okay? That I do know that unit, but these aren't cubed, okay? So let me show you what we're gonna do here. We're gonna take 1.34, our cubic meters over 1, just like we would normally with our dimensional analysis. And then I'm gonna put our conversion factor. Since this is meters, I'm gonna put our 1 meter here and our 100 centimeters on the top. Okay, now if I divide, that only gets rid of one of the meters, not all cubics. So what I have to do is I need to cube this whole thing. So I need to take 1 cubed, which is 1 meter cubed, and then I need to take and cube 100. So I can just take my calculator if I need to, and 100 cubed, right, of course, is 1, 0, 0, 0, 0, 0, okay? So essentially, this is my answer when I cube 100. So now what I have to do is my cubic meters are canceled out, okay, because I cubed everything inside. But now instead of taking my 1.34 multiplying by 100, I'm actually multiplying by 1,000,000, okay? So I'm taking my 1.34, multiplying by 1,000,000, and then dividing by 1, and I get 134, 0, 0, 0, 0, okay? So put in my commas here. So there's my answer in cubic centimeters, all right? Now, as far as significant figures go, I need 3 significant figures. I do have 3 significant figures. These zeros are just placeholders, so I can leave it like that, or I can go 1.34 times 10 to the, what, 1, 2, 3, 4, 5, 6 cubic centimeters. Give me my final answer in scientific notations. So the only thing I did there differently is I made sure that my conversion factor, that I cubed that value. I cubed everything, and I cubed everything on the bottom. So 100 cubed is 1,000,000 cubic centimeters, and 1 meter cubed is 1 meter cubed. Same thing. So that's the only thing I have to do when I'm dealing with cubes. If I was squared, let's say that this was squared instead of cubed, then instead of cubing everything, I would just square. So I'd do 100 centimeters squared, and I would get, and then I would do 1 meter squared. So it just depends if I have to square, cube, or even go to the 4th power, okay, or so forth. Usually we just either cube or square in this particular class, okay? All right, so that's dimension analysis. That gives us a good start on the process, the method of using dimension analysis to convert units. Study this video well. If you need to go back, please look at it again multiple times, but we got to practice. We got to take what we're learning here and apply it into some different problems, different scenarios that might come up, and practice, practice, practice. Okay, so that's it for right now.